This is a long-form video accompanying the first of my A-level chemistry speedrun series. So I'm just going through the exam question a little bit slower and talking through why I did what I did when I did it for each step. So in this exam question, we're looking at a sample of iron that has two different isotopes in it, and we've been given the relative atomic mass and we're trying to work out the mass of the missing isotope. So right from GCSE, you were familiar with this concept that we could work out the relative atomic mass of a particular sample by looking at the different isotopes and what their relative abundance were and kind of creating a weighted average. Now, just as a matter of personal preference, I'm not a big fan of using this long form of the equation. It does have its advantages in that, particularly if you're given abundance data that isn't a percentage, then using this system makes it much easier because, say, if you have a total abundance of 27, you can divide by 27. But I just have a lot of experience of people trying to do percentages with their calculator and things going wrong. So my personal preference is always to do this in terms of decimals, but you're going to get exactly the same answer regardless of whether you do it with long form fractions or with decimals. So the first thing I'm going to do is write out the equation, and then the second thing that I'm going to do is to substitute in the numbers from the question. So I've got this relative atomic mass of 56.2. I'm told that the first isotope, which has a mass of 56, has an abundance of 90%. So personally, I've gone for times 0.9, but you could do times by 90 and then divided by 100. And then for my second one, I don't know what the mass of that isotope is yet, so I'm just using X, and I know that it's going to have an abundance of 10% or 0.1. And the reason that I know that is that this is percentage data, and so all of my different abundances have to add up to be 100%. And in this instance, it's quite a nice straightforward question. I've only got two isotopes, so I can just do 100 to take away that percentage, or in this case, 1 take away that decimal. So now I can expand my brackets, and I know that 56 times 0.9 is 50.4, and x times by 0.1 is 0.1x. So then I can subtract 50.4 from both sides of the equation, and I get a 5.8 is 0.1x. And then if I divide both sides of that equation by 0.1, to get rid of that 0.1, I'm left with 58 is x. So at this point I'm done. But what I would also do at this point is a bit of a common sense check. So particularly with this kind of question, you can't guess exactly what the answer will be, but there's a limited range of options that it could be. So the first thing I'm going to do is say, has this isotope got a similar mass to the other isotope? Now, I'm not saying that you can look at this question and know whether it's going to be iron 57 or iron 58 or iron 59, but it's probably not going to be iron 27, say. So the fact that I've come up with an answer that is very similar to the isotope I already had is a really good sign. And then the other thing is that I already have iron 56, and I've got another isotope, and that's led me to have a relative atomic mass that is bigger than 56. So I know that the new isotope that I'm just finding out the mass of must be heavier than 56. So in this instance, 58 is bigger than 56, so we're on to a good thing there. Thanks very much for watching, and if you found this useful, then don't forget to like and subscribe for more A-level chemistry videos coming soon.